A clutch actuator is a critical electrohydraulic component that controls clutch engagement and disengagement in modern automated transmissions. Understanding its failure symptoms and root causes is essential for proper diagnosis and repair. The clutch actuator system consists of five key components working together. The electric motor provides actuation force, while the hydraulic cylinder converts electrical signals to hydraulic pressure. Position sensors monitor clutch position and provide feedback, while the control module processes signals and manages operation. The pressure accumulator maintains consistent hydraulic pressure throughout the system. When a clutch actuator begins to fail, several primary symptoms become apparent. Gear shifting issues are the most common, including difficulty engaging gears and grinding noises during shifts. Clutch engagement problems include slipping under load and harsh or jerky engagement. Dashboard warning indicators and performance issues like reduced acceleration also signal actuator problems. Advanced diagnostic testing reveals specific measurable symptoms. Normal hydraulic pressure should be between 60 to 80 bar, but failing actuators show pressure loss below 40 bar. Response time delays exceeding 500 milliseconds and operating temperatures above 85 degrees Celsius indicate actuator failure. Watch as these values change from normal to failure conditions. Root causes of clutch actuator failure fall into three main categories. Mechanical causes account for 45% of failures and include seal degradation, hydraulic fluid contamination, and normal wear and tear. Electrical causes represent 35% of failures, including motor failure, sensor malfunction, and wiring issues. Environmental causes make up the remaining 20%. Understanding these symptoms and root causes enables technicians to perform accurate diagnosis and implement effective repair strategies. Proper identification of failure patterns leads to more successful repairs and improved vehicle reliability. The first step in diagnosing clutch actuator issues is a thorough visual inspection. Check for hydraulic fluid leaks, damaged wiring, and corrosion around the actuator assembly. Next, use an OBD2 scanner to retrieve diagnostic trouble codes. Common clutch actuator fault codes include P0810, P0811, and P0812, which indicate clutch position sensor circuit malfunctions. Electronic testing involves checking voltage supply, measuring motor resistance, and verifying sensor output signals. Use a digital multimeter to test these electrical parameters. Hydraulic system testing measures pressure and flow rate. Normal operating pressure should be between 60 to 80 bar, with a flow rate of 2 to 3 liters per minute. Performance testing evaluates response time, position accuracy, and operating temperature. Response time should be under 300 milliseconds, and operating temperature should remain below 85 degrees Celsius. Based on diagnostic results, repair options include seal replacement for minor leaks, motor replacement for electrical failures, or complete unit replacement for severe damage. The replacement process involves preparation, removal, installation, calibration, using diagnostic software, and thorough testing to ensure proper operation. While DIY repair is possible for mechanically inclined individuals, professional service is recommended for complex electrical issues. Modern AI-powered diagnostic tools can now predict actuator failure up to 30 days in advance.